Qualitative analysis is the identification of cations and anions. Now, today in this experiment, we are going to test cations. Now, in the exam of paper 3, they give you a table of cation and anion in the end of the paper. Once we are testing cations, we have to use two reagents. Number one is sodium hydroxide, and the second reagent is aqueous ammonia. Now, there are two steps in which we will add these chemicals in our solution. Number one, we will add sodium hydroxide in a few drops, which can give us the observation of precipitates. That could be white precipitate, that could be faint white precipitate, or gray-green precipitate, or green precipitate turning brown, red-brown precipitate. So these type of precipitates will come in the few drops of sodium hydroxide also and aqueous ammonia also. Few drops includes the precipitation. Then we will add the excess of the reagent NaOH. The precipitates will either dissolve to form colorless solution or maybe colored solution, dissolve, soluble, insoluble, insoluble, insoluble. So the precipitates could be insoluble in excess or soluble in excess. In both of the cases, you can see in the aqueous ammonia also, they could be insoluble or it could be soluble in excess, right? So we test these cations in two steps of one reagent, that is few drops and excess. To test the cations in these 6 solutions using these two bench reagents, which are aqueous ammonia and aqueous sodium hydroxide. Okay, so for these 6 solutions, Fa1, 2, 3, 4, 5, 6, which we have been provided with, we will take their 1 centimeter depth of solution, and then we will add sodium hydroxide in 2 steps. Number 1, few drops, we will write observation here, and then we will add further 2 centimeter depth means excess, and we will add here. So we are going to test our first chemical given. We have taken its first 1 centimeter, but we will make sure that we will not add like this. We will tilt this tube a bit so that it will not splash. Slowly we will add 1 centimeter depth of this solution, and now you can see it's almost 1 centimeter depth solution. And now we will add sodium hydroxide in first few drops. Few drops could be any number of drops because these solutions with time gets diluted. Therefore, we will add few drops until we see a change. Again, in the same pattern, tilted tube, we will add in few drops, and here we can see the change is coming up. White precipitates formed, and then they start dissolving. Again, we will add few drops and then excess. So these are the few drops, and excess means the solution is making colorless solution. So white precipitates in few drops followed by colorless solution means dissolve in excess. Few drops addition of sodium hydroxide resulted in the formation of white precipitates, and then excess of sodium hydroxide resulted in the dissolution means soluble in excess. So it could be aluminum 3 plus or Zn2 plus that could be present in your Fa1 given. Now we are going to test Fa2 in the same way. We are going to test this Fa2 now. Again, 1 centimeter depth of this solution we have taken, and then we are going to add sodium hydroxide in the 2 steps, few drops first and then excess. So few drops resulted in the formation of white precipitates. Once we add an excess, the precipitate remains insoluble. In the second, we got white precipitates which are insoluble in excess. That is only Mg2 plus that is giving you these observations, and we can see in this table only white precipitates which are insoluble are there with this magnesium Mg2 plus. White precipitates insoluble in excess. We are going to test the third chemical now. 1 centimeter depth of the solution, and then we are going to add sodium hydroxide. Few drops gave me the observation of blue precipitates, and then once we add this solution in excess, the precipitate remains insoluble. Blue precipitates insoluble in excess means Cu2 plus is present in this. So we have Cu2 plus giving you pale blue precipitates insoluble in excess. We are going to test this fourth chemical now. We will take 1 centimeter depth of the solution first. And now we will test this with sodium hydroxide. Few drops first. So we can see green colored precipitates are formed. And then we will add this in excess. So the green precipitates remain insoluble, and we can see clearly the precipitates are insoluble. Precipitates can be seen from the top. And slowly these green precipitate from the top will turn brown on contact with air, since iron 2 gets oxidized in contact with air. So we will wait for a few seconds and we will see the color at the top of the precipitates will turn brown. Now we can see from the top the precipitates started turning brown. So in Fa4, the green precipitates which were turning brown with air and they were insoluble in excess showed that it contains Fe2+. So now we are going to test this Fa5 with sodium hydroxide. We have taken 1 centimeter depth of this Fa5. It's slightly greater than 1 centimeter, but it's fine because it's an approximate value, 1 centimeter depth. We will add few drops first. And we can see the red brown precipitates are forming. We will add in excess. So the precipitates remains insoluble, and we can see the precipitates are insoluble here. Red brown precipitates insoluble in excess means Fa5 contains Fe3+. Now we are going to test the sixth solution. Take 1 centimeter depth of the solution, and then we will add sodium hydroxide, few drops in the excess. So in the few drops of sodium hydroxide, white precipitates are observed which are dissolving very quickly. Yes, so the white precipitates in few drops dissolved in excess. Now, with sixth solution, I got white precipitates which were quickly soluble, dissolving. So it can be Al3+ or Zn2+. Now, if we are confused with the test of cation, that it could be Al3+ or Zn2+, here also aluminum 3+ or Zn2+. So we normally proceed with another test and for confirmation, and that is with aqueous ammonia. So in the table also we can see after sodium hydroxide, the second reagent we use to confirm the precipitates of these ions, we go for the second test, that is aqueous ammonia. Now, if they ask you to write ionic equation for these tests of cation, then we are actually adding sodium hydroxide, and sodium hydroxide contains OH minus hydroxide ion in aqueous form. And the solution, if it contains, for example, Zn2+, so we add Zn2+ aqueous. When it got OH minus, it forms ZnOH twice solid. The white precipitates are actually of zinc hydroxide solid. So we will balance this equation like this. And if we write any of the ionic equation for these, we will write in this way. For example, if I am writing for copper 2+, we will write this way. Cu2+ aqueous is getting hydroxide minus ion through sodium hydroxide, which must be 2, so that copper hydroxide's blue precipitates will be observed. Now, in the second test, we will take 1 centimeter depth of solution, and we will add aqueous ammonia in the same way as few drops first followed by excess. Now we are going to test this first chemical again in the same way. We will take its 1 centimeter depth solution, and now we will add aqueous ammonia in the same way. First we will add few drops. So in the few drops of aqueous ammonia, we can see white precipitates are formed. And then once we add the excess of ammonia, the precipitates are not dissolving, so they are insoluble. So aqueous ammonia addition resulted in the formation of white precipitates that are insoluble in excess. Now this confirms that Fa1 contains Al3+. How? Because white precipitates which were soluble in aqueous sodium hydroxide were for Al3+, and of course with the zinc 2+, white precipitates soluble in excess. Now if it is zinc 2+, then these precipitates must be soluble in aqueous ammonia, which are not. They are actually insoluble. So it confirms that it is Al3+. So in Fa1, we got Al3+ or Zn2+ possibility, which confirms that Zn2+ is not present, it is just Al3+ confirmed. So Fa1 cation is Al3+ confirmed because of the evidence here, white precipitate insoluble in excess in aqueous ammonia. Okay, now we are testing the second chemical, Fa2, with aqueous ammonia. We have taken 1 centimeter depth of the solution, and now we are going to add aqueous ammonia, few drops first and then excess. So we are adding few drops. Okay, so white precipitates are formed with few drops, and once we add this in excess, the precipitate remains insoluble. So the Fa2 contain white precipitates which were insoluble in excess when we have added aqueous ammonia, which shows Mg2+, and also we have the same observation, white precipitates which were insoluble, it confirms Mg2+. Now we are testing the third solution, taking its 1 centimeter depth solution and then adding aqueous ammonia, few drops first followed by excess. So firstly we have added few drops and the blue precipitates were formed, and when we add this in excess, the precipitates are dissolving and we can see that dark blue solution is formed. So Fa3 resulted in the formation of pale blue precipitate which were dissolving in excess to form dark blue solution with aqueous ammonia. So it shows it has Cu2+ ion. Now we are testing the Fa4 solution. We will take its 1 centimeter depth, and now we will test this using aqueous ammonia. With a few drops of aqueous ammonia, yes, we are getting these green precipitates, and then once we add excess of aqueous ammonia, the precipitate remains insoluble. If we look closely from the top, the precipitates are turning brown. The precipitates in contact with air are turning brown. Now Fa4 resulted in green precipitates which turned brown with air and they were insoluble in excess, confirms that Fe2+ is present. We are testing the Fa5. Take 1 centimeter depth of Fa5 and then add aqueous ammonia. Few drops first, and it is forming red-brown precipitates. And if we add in excess, these red-brown precipitates are insoluble. So Fa5 resulted in red-brown precipitates which were insoluble in excess in aqueous ammonia, which shows it has Fe3+ cation. Now we are testing this last sixth solution. We have taken 1 centimeter depth of the solution. It's a bit greater, but it's fine. It's an approximate volume. We will add few drops first, and it shows white precipitates are forming, and then once we add in excess, the precipitates are dissolving to form colorless solution. So white precipitates which were soluble in excess in aqueous ammonia resulted in the confirmation that out of these two ions, it is just Zn2 plus, so Al3 plus is crossed out. So now we have Zn2 plus in this. For the test with aqueous ammonia also, if they ask you to write ionic equation, we will write the ionic equation in the same way. For example, if we are writing it for Fe2 plus, we will write this way. If Fe2 plus aqueous solution is added with aqueous ammonia, it gives off OH minus ion. So what will form? FeOH twice solid. Green precipitates are of this solid. In the same way, if any of the cation you have to write ionic equation, you will write the same way. Hydroxide minus aqueous is forming its hydroxides precipitate. So these are the blue precipitates of copper 2 hydroxide.